We're going to use a ratio test to determine whether this series is convergent or divergent. So we take the absolute value of a sub n plus 1 over a sub n. This is going, and we're taking the limit as n approaches infinity, of course. Limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So we're just going to plug in n plus 1 wherever we see an n for the numerator of this thing. 100 to the power of n plus 1. This is our numerator, n plus 1 factorial, and our denominator is going to be unchanged. So this is n to the power of 100 times 100 to the power of n over n factorial. We can rewrite this so that we can multiply by the reciprocal and start canceling stuff out and grouping things together, which seem like they should be grouped together because they have some similar exponent. So we will get n plus 1 to the power of 100 times 100 to the power of n plus 1 over n to the power of 100 times 100 to the power of n times n factorial, because we're multiplying by the reciprocal, so that's the denominator going up there, and the denominator there stays in the denominator, n plus 1 factorial. Okay, so now we can see that we have certain things which are to the power of n, certain things which are to the power of 100, and we have stuff that's going to cancel out because of the n factorial. So what I would do first is group everything that looks alike together. So let's group it. Limit as n approaches infinity of the absolute value. Okay, we have something to the power of 100 and something to the power of 100. So we could have n plus 1 over n all to the power of 100. We have 100 to the power of n, which would cancel with 100 to the power of n. And we're still left with another 100, because we can, by the exponent properties, expand this into 100n times 100, because we had 100 to the power of n plus 1. So these two guys cancel away, and we have 100 in the numerator. So we would be multiplying this by 100. And this thing is nice because we have n factorial, and we have n factorial that we can factor out from this one. We could factor out n factorial from this and have n factorial times n plus 1. And that's the same as what we had before. If you don't believe me, you can plug in numbers. So let's say we have 5 for n. If we have 5 plus 1 factorial, that would be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. That's the same thing as this, because if we had it in this form, we would have 5 factorial times 5 plus 1, which would be the same thing as 5 factorial times 6, which is the same thing as this, right? Because we would have 6 times 5, and then apply the factorial on the 5, and you get all the other numbers. So these are equivalent. And we can therefore cancel n factorial from the numerator and n factorial from the denominator, and we're left with 1 over n plus 1. 1 over n plus 1, and that's how we're looking. We could have the 100 multiplied to that 1 in the numerator, and we have less terms. So that's how we look at the moment. Now we could take the limit as n approaches infinity. So we divide everything by n on this side. Limit as n approaches infinity. We divide everything in there by n, so we get this, and we're multiplying by 100 over n plus 1, we're going to plug infinity into there eventually, but let's take it step by step. This becomes a 1, this becomes a 1. And if we plug, now let's go ahead and plug infinity. If we plug infinity into here, this becomes a 0. This becomes a 0, and this entire thing becomes a 1. If we plug infinity into here, we get 0 for the whole thing, because we're dividing 100 by infinity, and any number divided by infinity is just going to go to 0. So we have something being multiplied to 0, which is just 0. And 0 is less than 1. 0 is less than 1, so this absolutely converges by the ratio test. Absolutely converges by the ratio test because 0 is less than 1.